Hello everyone. In this video, I want to share with you that the details of the use with parametric, object-based triangulated irregular network progressive encryption filtering. In the previous chapter, we have introduced the principle of the object-based triangulated irregular TIN progressive encryption filtering method, which will not be repeated here. However, it should be emphasized here that the entire filtering framework is the same as that of the traditional point-based triangulated irregular network progressive encryption filtering framework. The basic unit we deal with here is not a point, but a plane or a smooth surface object obtained by point cloud segmentation. This filtering process is divided into 4 major steps. The first step is to initialize the categories of all points. The second step is the gross error detection and elimination. 2 methods are designed in our software. Users can choose the corresponding gross error detection and elimination method according to their own needs. In addition, it should be pointed out here that our software assumes that the point cloud data does not have gross error by default. If you do not modify any parameters in this step, the software will not perform this step. The third step is the point cloud segmentation algorithm mentioned earlier. The main work of this step is to extract the smooth plane or surface from the point cloud data. Due to our continuous improvement, our algorithm has achieved adaptive terrain. Therefore, the user does not need to adjust the parameters accordingly. The fourth step is the most critical and core step. We can see that the relevant parameters are mostly consistent with the parameters of the classical triangulated irregular network progressive encryption and filtering algorithm. There are several important indicators. The first and most important indicator is the maximum building size. How to judge the largest building size? We can actually measure the diagonal distance of the largest building in the point cloud data, and we can consider it as the size of the largest building. Several other indicators are also important, such as iteration angle and iteration distance. In addition to these 3 important indicators, another indicator is the length of the edge. This indicator is actually used to control the sparseness of irregular triangular network cloud data. For example, when the edge of a triangle is less than 2 meters long, no new points are allowed to be inserted into the triangle. Of course, the parameters of this edge length can be adjusted. In addition to the 4 parameters mentioned above, there are other less important parameters. For example, terrain inclination, whether multiple pulse information is used, and whether it is sensitive to outliers, gross handicap. It should be pointed out here that if our point cloud data has a small amount of low-order gross error, we need to turn on this option. Another option is whether ground points are thinning and smoothing. Next, let's take a look at how to filter point cloud data in combination with the actual operation of the software. This is a mountain point cloud data, and the point cloud data itself is with color information. For this point cloud data, although there are many trees, but the quality of the understory data is still relatively good. Let's first open the data and measure the length of the largest building size. Click the Point Selection tool, select the second item, and measure the distance. Because this building is a composite building, the length of the diagonal line is about 31 meters. Next, we will process the practical data. Load the data into the Toolbox software. Here we use the version with parameters. As we can see, the default maximum building size is 50 meters. The maximum building size we measured before is 31 meters. Here we take a slightly larger length, such as 40 meters. We don't think it is necessary to change the other parameters. So click OK to start processing. During this period of data processing, we share some knowledge with friends. In fact, for the irregular TIN progressive encryption filtering algorithm, the meaning of the maximum building size we think should be the size of the largest opaque feature. The size of the opaque features includes both buildings and opaque woodlands. Therefore, users need to understand the meaning of this parameter in the process of using it. It took less than 2 minutes to complete the data processing. We load the newly generated file into the viewer software. Let's just add in the ground points and look at the effect of filtering. Let's take a brief look at it first. The trees have been successfully removed and the ground points under the forest have been well preserved. The building was also successfully culled. Let's take a look at generating a digital elevation model. It should be pointed out that where the terrain is broken, such as steep ridges, road edges, terraces, etc., the ground point extracted by the software is very good. You can contact us by email at jonas_zinc@gmapp.com or WeChat at +86 13888837 1238. Alternatively, you can obtain a trial license by filling out the relevant information on the website https://www.thjymap.com/pca. Thank you for watching and see you next time.